Hello, Pepin Falcons. This is Mr. Newber. I know it's time for a lesson, but I just wanted to check one thing. I was out here this morning and I want to check my tricycle and make sure that it still works. So I'm going to be with you if just give me 30 seconds, all right? And I'll be right with you. Hold on. Here we go.
You okay?
Oh,
Hey, how you doing?
Hey,
Good, how are you?
Look who's here. Look who's here, you guys. It's Coach Jimenko.
What's up, guys?
Woo!
Good to see
Can I help
you.
you with the math?
Greetings, fellow Falcons, and welcome to another edition of Math is More Than Fun at Pepin. I'm your host, Mr. Newber, and today we are going to begin exploring the addition of fractions. I'm so excited about today's lesson, I'm actually wearing my best tie. What I'd like to do with all of you first, however, is to review in just a minute, just take 1 minute to review what we learned about fractions before. This is Tommy the Turtle. You'll have to wait. All right. You remember we defined a fraction. A fraction is simply two numbers in a line. That's all it is. You look over here at these examples of fractions. It's two numbers in a line. And in order for it to be a proper fraction, which is what we're teaching now, the number on top has to be smaller than the number on the bottom. This is almost as simple as sitting down to a dinner and knowing what to do with it. All right. Two numbers with a line. The one on the top is the numerator, the one on the bottom is the denominator. And very simply, a fraction shows that something, a whole something, was divided into equal parts. Okay? And the number of parts in the whole thing is the denominator. And the number that we're referring to, that we have in our hand, that we can see over there in the corner, whatever it happens to be, that's the numerator. Before we can add two fractions together, we have to come up with some fractions. So I decided that one of our categories that we're going to use to create fractions would be years. And here's my thinking. I know you can follow along. One whole year, we're talking about a whole thing. The entire year is 12 months. All right, everybody knows that. January, February, March, April, May, all of those. Okay, we are not counting days or weeks. We don't care if there's 52 weeks, and that's not what we're doing for the year. Our two numbers are going to be based on a year and the months. The year is the whole that I spoke of, a platter falling on the floor and shattering, and it's broken up into 12 months. Those months are equal because there's always 12 of them in a year. Every calendar has 12 months in a year. Every calendar shows 12 months in a year. There's the number. So if we are building fractions about a year, then that must have what in the denominator? Go ahead. Manny, Kylie, what's it have to have in the denominator? That's right, 12. There must be a 12 in the denominator. So now let's see if we can build a fraction out of something else that you are familiar with, and that is a baseball season. How many years is a baseball season? Well, hopefully, since they play a different season every year, we're going to be talking about a proper fraction. We want to talk about less than 1 year for a baseball season. All right? Less than 1 year. So how many years is it? It's going to be a fraction. So can the baseball season be measured in months? And you see the answer there in red. Yes, a baseball season can be measured in months. I'm not talking about spring training, and I'm not talking about the playoffs over here and the World Series. I mean, when does everyone play baseball and it counts? Well, it starts in April, then May, June, July, August, and September. That's how many months? Well, that's what we want to know, because we want to build a fraction with 12 in the denominator for the number of months. So this is 1, 2, 3, 4, 5, 6. We can safely say, look at this proper fraction here. Isn't this exciting? A baseball season is 6 months out of every 12 months in a year, or 6 over 12. Now, one thing you must understand about fractions in math class, when we're talking about quantities, when we're talking about things that you're familiar with so that we can build fractions and add them together, everything is perfect. If you remember, I mentioned to you pizza. If we're going to divide pizza, every pizza has to exactly, to the crumb, be exactly the same. Every slice has to be exactly the same. And that's because, well, math is perfect. That's why it works that way. So, how much of a year is summer? Well, down here in Florida, it's usually, what would we say, March through November. But that's not perfect. Perfect is June, July, and August. Pretty much all across the United States. So how much of a year is summer? What's the fraction of a year that is the summer season? Go ahead, you can write that down. And then while you're at it, the second question is, how much of a year is winter? And winter, generally speaking, is December, January, and February. The most snow, I know, I lived up north, the most snow falls, yeah, it snows at Thanksgiving, but not every year. And it snows at Easter, but not every year. It's December, January, and February. So if you came up with this, you win the prize today. It's 3 months out of 12. And winter is 3 months out, 3 months out of 12. Okay? They're identical because we're talking about the same thing. We're talking about divisions of the year into seasons. Here's what we're doing today. How much of a year is both summer and winter? We're just going to add these fractions together. Do you think we're going to add the 12 and 12 and get 24? Is 24 going to fit anywhere in the answer? No. So what we're going to add here is 3 over 12 plus 3 over 12, and our answer has to be the 12. The 12 months doesn't change. That's not going to change. All right? But the 3 plus 3 is 6. So the answer to our question down here, how much of a year is both summer and winter? Well, we said it was 6 over 12. There's 3 for the summer in there, and there's a 3 for the winter in there. 3 plus 3 equals 6. 6 over 12. And that's how you add fractions. The denominator here must be the same. You add fractions, proper fractions, and the denominators must be the same, and that shows up in the answer, and you simply add the numbers in the numerator. Nothing to it, right? Great. Okay, it's always nice to take a little break. Okay, so now we're going to work with pizza. I know immediately when we came on here, okay, and I like using something that everyone is familiar with. We all know about pizza. All right, now I want to repeat. All pizzas in math class start, and at the beginning, where they start, they are exactly the same. So please, don't write to me, don't send me a text or anything and tell me this actually looks like an egg, and this is a smaller circle than that one. No, it's not, because this is math class. Those are all exactly the same size circle. And if you insist on those being the same size circle, well then this portion of your education is going to take about 3 years, because I'm going to have to get a compass in here. But you can imagine that these are simply circles, and they are all exactly the same. And here's the most common one down here on the end, right? 1/2. This is 1/2. There are 2 slices of pizza in here. 2 of them. That's the grease stain on the bottom. It turned out blue. All right. One of them's gone. So how much of a pizza is in here? 1/2. 1 out of 2. These are man-sized slices here. There's 3 of them here. So if I'm talking about this one and this one's 1/2. If I'm talking about these 2, well, okay, there's two of them there. But how many did we start with? We started with 3. So that shows 2/3. This one, of course, is 4. That's going to have 1, 2, 3, 4. That's going to have a 4 in the denominator. This one has 5. That's going to have 5 in the denominator. This one's going to have a fraction of 6. No matter what we're talking about with the pizza in there, no matter what we talk about, the denominator has to be 6 because we started with 6 slices, all right? I very rarely do 7 unless it's in a problem. I'm going to skip right to 8 because this is the one that I'm going to be drawing. If I'm showing you how to do fractions, whether it's this year or next year, and we're adding them, subtracting them, and so on, and we're trying to work through fractions, I'm going to draw that. You can ask students at Pepin, you can ask the seniors. I always draw an 8-slice pizza on the board, and then I color in whatever that we're talking about. The number up here, of course, is going to be less than 8 because it's going to be a fraction, a proper fraction. All right. So when we're talking about pizzas, remember, we're not adding these together. If I wanted to add something to this pizza right here, I would have to do this. I'd have to draw another 5-slice pizza. Now, Andres, I know, Andres, that slice is not the same as that one, but actually, yes, it is, because this is math class. So that's exactly the same slice as that slice. This slice, however, is not the same as this one. This slice is not the same as this one because this pizza gave 6 slices. This one gave 8. These slices are going to be bigger than this one. But when we are going to add fractions like this, when we're going to add fractions, let's say we had 2/5. This is a 2/5 pizza up here. And there's 1 slice down here. So this is a 1/5 slice here. We're going to add these 2 together. And I think you can see it's going to end up 3/5. But this is why I wrote this up here, and I hope you write this down or make a note of it. Adding fractions is like taking pizza slices out of one box and putting them in another. That's why I use pizza, because you can get more of a mental image of what's going on. So all of these problems, if Mrs. D gives you a page of just fractions adding together, every problem that she gives you is going to have the same denominator. All you have to do is add the numerator. And if you want to picture pizzas, then go ahead. You want to draw them on your page, please do it. Do it, because pizza is easily understood. If you have a pizza party, probably going to be more than 1 box of pizza, right? If they're perfect math pizzas and they're sliced exactly the same, well, at the end of the night, are you going to put two boxes away, or are you going to put the slices out of one, put it in the other, and put 1 box in the fridge for the next day? Of course, you're going to take them out of here. That's adding fractions. Isn't this great? So that Timmy, take it easy. Take it easy. Timmy, the turtle's going on. All right, that's all adding is. All right? So our goal in math class as instructors is to have you add numerators, keep the denominator, and do it without having to have the visual. But if, like I said, if you want to draw pizzas, I can show you how. We can have a lesson on that and have some fun with it. Yeah, settle down, you guys. All right? So this was the class today. All you're going to be adding, here's a sample problem, and I'll use the one I didn't put up here. What is 2/7 plus 3/7? That's a good adding fractions problem that you might see maybe tomorrow, maybe the next day, maybe next week. All right? Well, first of all, you know we can add them together because it slices a pizza from the same type of pizza, 7 slices in each box. So there's 2 in this box and 3 in that box. That's going to be 5/7. And that's the class. I can leave this up for a little bit if you like, and you can write some of this down if you want. These are kind of fun to draw, but if you don't have to draw them, then that's very good. Then just practice adding them. You're simply adding 2 numbers that are less than the denominator, and that's the point in adding fractions. That's all you have to do. Okay? Good day.